Please take your seats. Welcome to Convocation. Hope everybody's doing well. This morning's Convocation speaker is Ken Cook, and here to introduce Ken is Senior Jared Kaufman.
Good morning. Thank you. Ken Cook is the current meteorologist in charge at the National Weather Service office in Wichita, Kansas. He's had a love for weather since he was 8 years old, and he graduated from Florida State University in 1992 with a Bachelor of Arts in Meteorology. He's held this position in Wichita since 2016 and specializes in the fields of winter forecasting, lightning flash density, and grassland fire weather, to name a few. Ken's LinkedIn page further describes his broader focuses as including servant leadership and being a faith builder, leader, and Christ follower. So without further ado, let's give Ken a warm Bethel welcome as he comes to present for us.
Good morning, everyone. It's a pleasure to be here. Just want to thank everyone who is involved in having that happen. It was a very good experience and good pleasure, and I hope you all enjoy this presentation. And so, just to give you an overview of what we're going to do here, we had a pretty big event across Kansas on December 15th. Does anyone remember that event? Okay, some of you did. That's good. And so what we do at the National Weather Service, and I'll go through this here in a bit, but we produce all the watches, warnings, advisories that you see scroll across the TV, the wheel alerts that you get on your cell phone. We do that at our office. That's what we do there. And so our job, our goal is to protect people's lives, help them understand weather safety, and also help them protect their property. So we'll go through some review here of just what the National Weather Service is and does. We are a federal government agency. We are located across the United States and all of our U.S. territories. There's over 120 offices across the country and its territories. We are responsible for all those watches, warnings, and advisors that you do see. And our specialty is weather, water, and climate. And so the partners that we mainly deal with is the general population, you all. And we also deal with the government agencies. This includes state emergency management, federal emergency management, FEMA, many of you have heard of them, and other government agencies. We also work a lot with the media, and that includes TV and radio and social media. We are under the Department of Commerce, and then NOAA, which is the National Oceanic and Atmospheric Administration, and then the Weather Service falls under them. We take up almost 2/3 of the employees, or size, if you want to call it that, of NOAA. That's where we get most of we are most of NOAA, I guess I'll say it that way. We do have over 4,000 employees in our agency. As far as the Weather Service office in Wichita, we're down off Tyler Road, where the big soccer ball is that people like to refer to it. We do have, and we're fully staffed, which is rare, 23 employees. We have 16 of those are meteorologists. We have an IT. We have someone that's the observations program leader, and what he does, we have about 100 people that will take observations once per day and send that information into us so we can make better forecasts and things of that nature. And he manages that program. We have a service hydrologist, and she deals with all the water resources, the dams, the rivers, the forecasts of all that information throughout the, across the area that we serve, which is 26 counties. We have 3 electronics technicians who keep the equipment going and service the things that we need, such as the radar, our observing equipment, our computers, and then we have an administrative assistant there as well. We are a 24/7 by 365 operation. We have a minimum of 2 people on staff at all times at the station, and that does present interesting things when you have people that want to take off and emergencies and whatnot of that nature. This is the area here that we serve, this tan area here, Newton, and where you all here are over in this part of Harvey County, and those are the 26 counties that we serve. The offices that also serve Kansas is Dodge City, Goodland, Kansas. This is the Hastings, Nebraska office. This here is the office in Topeka. Springfield, Missouri, and Pleasant Hill, Kansas City serve those locations. So we have 7 offices that serve the state. And just a little bit about me. I decided when I was young, and most meteorologists are this way, because you get this little bug about, man, I think the weather's really neat. And I started that when I was about 8 years old, and probably drove my parents nuts listening to the weather radio at the time constantly. I graduated and then went to community college for a while and attended Florida State and graduated in 1992. I was a temporary meteorologist in 91 at West Palm Beach Weather, and then in 92 in Tallahassee. And then I went to work at the Raleigh-Durham Forecast Office in the mid-90s. And I was a programmer up in Washington, D.C. for a couple of years after that, and then decided that I don't like traffic that much, and it was miserable. So I went to La Crosse in the late 80s or late 90s, all the way into the mid-2000s there as a forecaster and then a lead forecaster. And then I came down here in Wichita in 2005 and was the primary scientist in research and development and operations leader at the office in 2005 to 16, and I've been in charge of the office since then. So as Jared mentioned a little bit, these are some of the areas that were my primary areas of research. A lot of winter weather here, also severe weather with non-supercell tornadoes, discriminating environments between tornadic and non-tornadic storms, lightning. We have flash flood stuff going on here that I did a lot of research with, verification events. But what we're really going to talk about a lot today is that last one, grassland fires. And so I just want to give you a brief history of what grassland fires and the fires in this part of the country and how that's evolved until now. In 2005, when I arrived here, there was no real fire program in place here in any of the Kansas offices. And since then, it's really taken a change. And a lot of that's driven by the need. So in 2007, we issued our first fire weather forecast from the office. And this increased a dramatic increase in the amount of spot forecasts. And what those are is sometimes you'll see big smoke plumes in the middle of the day. So what happens is if somebody wants to burn, they'll send in a spot request, and we'll give them a forecast of the weather conditions at their specific location for the next 12 hours. And that helps them understand, should I burn or not? Because the last thing somebody wants to do is get a fire out of control. And we'll talk a little bit about that later. And so in 2006 to right now, there's ongoing tool development and fire prediction. Really, we had nothing more than relative humidity and wind combinations back then. And some more notable fires that have really driven this research recently is the Anderson Creek fire that burned nearly 400,000 acres across Kansas and Oklahoma. That was started by a tire capping that rolled off a truck into a grass area. So you just don't know what's going to cause a fire on these bad fire weather days, okay? It could be lightning, it could be something like this, it could be an old burn pile. So we've really learned a lot. And then a year later, there was a Starbuck fire that burned over 660,000 acres in Kansas and Oklahoma. So why is this happening? Well, if you look back in the Dust Bowl era and you read a lot of the literature that was back then, you will see that amongst the blowing dirt and dust and all that, there's a lot of soot involved with there. So plains fires have been ongoing for a long time. This is not something new. It's the intensity of them that's changed. And what's really caused that is there's just an increasing fire suppression, and has been for about 100 years of fire, and that's more nationwide. But on the plains here, it's no difference. And perhaps the biggest thing here are these eastern red cedars, and you'll see them along fence lines. You know, birds help propagate them really well. And really, when you get into seeing this type of landscape, if you go out and see an empty field, if you do not manage that field, in 40 years, it'll be completely covered with these trees where you can't even walk through it. It'll be completely forested. So if you drive down to Oklahoma, this is really bad down there. You'll see forests of these things, and the fire people have been trying getting people to just cut them down and get rid of them because they're a significant fire hazard. And in fact, there's some literature here that's really gone on about this since the mid-90s all the way up until a few years ago, that the proliferation and growth of these things, and they have become more of a pest species, really have been fueling this fire problem that we have, because they are very volatile. They burn really hot, and they can cause a lot of issues. So just keep that in mind as we go through what happened here. So as we think about why fire occurs and that nature, there's a few main ingredients here. You really want your fuels dry. So when you go out, you look out, maybe some trees out here, or you look at grass or things of that nature, there's something called how long it will take for that to dry. Well, I won't get into the too technical term, but for example, a grass is a 1-hour fuel. It takes 1 hour for that grass to be cured to burn. If you get an established tree, it's a 100-year fuel, or maybe a 50-year fuel. So how long does it take something that's dead to cure so it will burn? And that's what we're really talking about here. So grasses are a 1-hour fuel. Maybe you have little herbaceous weeds out there that are a little thicker, twiggy. Those are 10-hour fuels. So that's what we want is dry fuels, okay? Wind, obviously, is a big driver of these, and we'll look at this case here on December 15th. And see how that happened. Low relative humidity, again, we want dry and warm temperatures. And this red flag warning, I'm just curious, has anybody ever heard that term, red flag warning, before? Okay, that's more than I expected. So this used to be just an internal deal for our fire people, and that really is helping them understand. We have a fire day that's in the top 90th percentile. In other words, out of 100 days of fire, this is one of the 10 worst that we're going to have this year, okay? And the other thing that this is, it helps them prepare. What kind of resources do we need? Do I need to have fire trucks? Do we need to get the Black Hawks ready to do fire suppression? These are the type of things that help them understand what kind of day we're expecting so they can prepare resources. So some of the things that help us do that now, we're developing these tools like the Grassland Fire Danger Index. That's been part of our fire program now since 2006. That we adapted that from the Bureau of Meteorology, which is in Australia. We had a forecaster go there, and she came back, and we started doing this, and now most of the offices on the plains use that. There's the Red Flag Threat Index that's started by the office in Norman, Oklahoma, and we are all using that as well. And then there's more of this recent hot, dry, windy. And so we have these indices or these tools that take all these things that we're looking at here above, put them together in some kind of a nice, neat number, and help us understand fire prediction. So that helps us message those types of things. And so what I'm going to do here is talk about the December 15th, 2021 event, which was really big here. And I've been around for a while in this agency, about 29 years, and I've seen a lot of interesting events. And this was having to be, I would say this is the most diverse weather event we had, at least in my time in there. And I've seen a lot of big outbreaks and hurricanes on the East Coast and whatnot. But the thing that made this special is we had a lot of different things. We not only had the fire threat, we're looking at severe weather that day. We're looking at the wind speeds high enough to blow tractor trailers off the road, cause damage at people's homes. And also we have the blowing dirt and dust that's a visibility problem when you're driving. So all four of those happened this day, and we'll see how that event unfolded. So we just talked about that. It was very dry. We hadn't had up until this point any measurable rainfall across the bulk of our area since the first couple of days in November. So it was dry for quite some time, okay? Very low relative humidity for that day. The forecast wind speeds were in excess of 60 miles per hour. So I want to know, how many people are not from this region of the country? Used to the wind yet? Took me a while. You have to embrace it. It's the only way around it. So it was expected to be in the mid-70s, which is pretty warm for that time in December. And we were expecting multiple hazards, as I just said here. So just to give you an overview of what happened here, this here is an upper level low pressure here that's moving out of Colorado. It's up around about flight level 35,000 feet. And that's in the morning. By evening, it's expected to move up toward Omaha, Nebraska. This is a low pressure. I'm sure we've all watched the news and see, a cold front or whatnot coming from these, but this is over southwest Nebraska. That's also expected to move northeast. But I am going to get into a little bit of the science nerdness here. When you start getting to these lower colors, it means that it's really a lot stronger than typical low pressure systems are that time of year, or it's anomalous. And so this is moving up toward Minnesota and Wisconsin, and this event also caused a bunch of tornadoes up here in this part of the country, which is pretty rare for that time of year. So this is a forecast of just the relative humidity, and we think of relative humidity as basically a measure of how much moisture is in the air. And this is in the morning of that December 15th, at about 1 in the morning, about midnight actually. And then as the day goes on, we're over here. And we're actually going to focus out here, out near Russell, Kansas, Hayes, that area. It's pretty dry by about 6 a.m. and into noon hours. It really gets dry into the evening. So you can see this dry air is coming up in here. I'm trying to give you kind of a thought process as forecasters of what we're looking at, just to give you an idea of how we do this. Some people think there's a big dartboard at the office. That's just not true. So here's an interesting graphic that we get to use from the Kansas Mesonet. Look how dry the soil is here, and this is the 4-inch soil depths. Some of you that are involved in agriculture know all about soil moisture and that type of thing. This is the soil depth, or the soil moisture at 4 inches. It's incredibly dry out here, especially out west. It's down in the 99th percentile of dry, so keep that in mind. This here is a measure of our fuel status and how dry it is. These are percentiles. You can see it's really dry up here. We're in the 90 to 96th percentile. And like I said earlier, if you had 100 events, this would be somewhere between number 6 and 10 of the driest ones. So that's just to give you a plain measure of what we're looking at here. This is our forecast wind speed. Again, we're looking at 60 miles per hour here in Russell, Kansas, 60 out here, and all out here in central Kansas is all around 60 miles per hour. And even out here in eastern Colorado, we're looking at mid-60 wind speeds. So just remember those numbers, and we'll see what actually happened here. Just to give you more of this anomalous business, again, this is the 99th percentile, so 1 out of 100 events across Kansas. When we like to think of thunderstorms, I didn't know if I wanted to throw this in here. We talked about the thunderstorm threat. One of the things that we like to look at is just how unstable the atmosphere is. In other words, if you have a balloon, in other words, if you think about that as an air parcel, you have a balloon, is it going to rise or not? And how fast is it going to rise? Well, this is what we're measuring here, is how fast that balloon or that air parcel is going to rise. And we need air to rise, to clouds to create, and condensation and thunderstorms to develop. Okay, so this right here shows that we have a lot of energy out there for the air parcels to rise and create storms, which then leads to severe weather. Okay, so it's pretty anomalous. These light red is the 95th percentile. So it's, again, pretty rare. That's the main thing to get here. So this is the Grassland Fire Danger Index that we had done before. I've never seen it like this before, ever, in my history dealing with this, which is about 12 years now. And so it's basically maxed out over this whole area at 150, which is really in the catastrophic category. So I know I'm going through these a little bit quick. Here's the red flag threat index. We're up in the historical context again out in that area, and that's the hot, dry, windy. So I guess at this point, do you think it's ready to burn? I mean, have I proved my point? All right. That's the storm prediction. They even believe it's going to burn, so I guess it's going to burn. So at 4:53 in the morning, we sent out this information packet to our emergency management and media partners and those other government agencies that we deal with. A historic wind day, all right, with gusts from 50 to 70 miles per hour. It's going to basically be most of central and south central Kansas. Okay? We talked about damaging wind gusts up to 70, and again, the extreme grassland fire as well. So everybody's ready to go. It's 5 in the morning. The midnight shift's getting tired, you know. So they go home, and right at 8 o'clock, we get an update to this is a severe weather outlook. And again, remember I talked about the tornadoes up here. They brought the marginal area down to eastern Kansas, and we thought, okay, you know, we might get a few thunderstorms. We'll see what happens. But it was dry. We didn't really know exactly how much moisture would come up into the area. So at 9:15, we have an operations briefing every day that we all get on, and we talk about what we're expecting for the day and the next coming days. So everything was in good shape. The one thing is that some of the later numerical model runs that come in that we look at, we're showing some of the wind to the north, are moving a little bit further north than we expected, and then again moving the marginal severe outlook south to just east of 135. At 9:42, we're sitting there at the office, and this is a picture of the petrified wood building out there in Lamar, if you've ever seen it. I haven't, except with that picture. We saw a wind gust come in of 107 miles per hour. So that's a little bit above 65, right? So we're like, okay, this might be an interesting day. So we'll keep our eye on that. You know, they have some winds that accelerate when they come out of the mountains downslope, so it wasn't too alarming, but it was something to take a look at. So at 10 a.m., they drew a surface map here, and they don't do it like they do on TV. We're just lazy, I guess. But there's the cold front here, and then there's the warm front up here that goes up into Nebraska. There's a dry line. If you've heard that on the plains, if you've been here in the plains, you've probably heard the dry line. And all that is a difference between moisture and moist air and dry air. You typically see that in severe weather season. And these little arrows here are where that 35,000 foot layer strong wind maximum is located. So we did that. It's 110 knots, which is about 135 miles per hour if my math without thinking serves me right. And so here's a 1-minute satellite loop at noon. So we're looking at this at the office, and this is what we're looking at. These black dots here in the Texas and Oklahoma panhandles, those are ongoing fires. And we can see that now with the new satellite, so long as there's no clouds in the way, since they put that up in 2016. You see this little dark area? Well, let me do another loop and show the enhancement of that. That's what this is right here, when you see that. Anybody have a guess what that is? Dust. You're right. So here's the fire down here, and some of these are image enhancements, so here's the fire down here. That's the dust coming. So they see that, okay? All right. So then we get a picture, because we monitor Twitter and social media and that a lot, and we start getting this type of thing in there. So there's the big dust cloud out there that you're seeing, and this is somebody that wants to drive in dust, I suppose, or has to get somewhere. That doesn't look fun. So what do we do? Well, at 12:14, they put out this graphic to our partners again about the dust, okay? And just highlight this area over here in central and eastern Kansas that's heading that way. Here's the blowing dust. Wind gusts 60 to 75 still. Visibility less than a half mile from that social media post. So if you're ever out and you see weather, it's important to send it to KSWX hashtag. That's the hashtag KSWX, because we see it and we'll use it. And some guy in the middle of the afternoon might contact you to use your photo like I did. So the other thing we got was the emergency manager, Keith, up in Russell County, said I-70 will be closed west of there because of poor visibility. So now, about an hour or so later, now we get thunderstorms popping up. So I-35's over here. We're expecting it over here, at least the Storm Prediction Center was. Well, here we go. So we issued the first warning over here out in central Kansas. That's what the yellow box is for a severe thunderstorm. Expecting winds, again, of 75 or more miles per hour from the wind. So things are starting to really unwind here, unravel, get going, however you want to look at that. Here's the updated 2 p.m. satellite loop. That's a lot of blowing dust, isn't it? Here's the first fire, significant one in Kansas, right out here. So, not too much longer, there's the first hotspot notification. Well, what's that? So we have a little app, or if you want to call it that, on our workstations there. And since we can detect the satellite, the fires on the satellite, and we get new scans of the satellite every minute, we send out what's called a hotspot notification. And so these are all the ones that were issued that day, and I couldn't take them off. But the first one up here in northwestern Russell County was issued at 2:17 p.m. And what that does is we push a button and it texts all the emergency managers and emergency manager and all the first responders in Russell County and the counties around it, so they know that we see a fire. And we will beat 911 calls on an average of almost 8 minutes. So this is about an hour later. You see there's a lot more fires in here, and I'll show you why the reason of that is. But the 4-county fire, which is the one that burned a lot of acres, is just starting here. So over the course of about 15 minutes, it really starts to explode there. There's a couple really interesting things that happen here all at once. But that's what the 1-minute satellite data looks like. Here's a closer view of that. Again, here's the 4-county fire, and I can tell you that's a whole lot of fire in only 15 minutes. So again, here's the road closures as of 3:30. You can see the interstates, some of the state roads here, trying to get my bearing, so that are all closed because of the dust and everything that's ongoing. There's the severe storms that are off to the east, but road closures were really underway big time. So this is the imagery from about 2:30 to 3:30 in about an hour. Look how big this fire's gotten. There's like 4 communities up there that were in the middle of that needed to be evacuated. It was a real serious issue. So we're in the office, we have road closures, we've got semis being blown over on the road, and Trooper Ben and a few of those others were telling us all about that. And then we have those severe storms that you see here going on across the state that's just getting past the metro area. And then now we got this massive fire out here, and that's a real danger. Here's a closer view of that. So notice right behind this area here how they've just really blown up. And there's some really strong winds in there. Here's another view of that. This is right when we got a reported gust in Russell of 100-mile-per-hour wind gusts there. And that was right in that 4-county fire area. And this is right when it came in, and you can see the red enhanced area of the fire. There's a couple things I want to point out here. So if you look in here, a lot of fires, and if you look at the clouds and we go back to the loop, they just kind of dissipate and go away. Well, what happened there is, if you know how things work, when you go down in the atmosphere, you dry. When you go up, you get moist. That's why rising balloons or parcels turn into clouds and storms. Well, what happened is there's a big low-level jet that developed in here and dried the clouds out, and that's what was blowing down. The reason all those fires started is it was blowing down power lines and high-tension ones as well. Those are rated at 95 miles per hour. So it's blowing all them down, and so all this entire area here is seeing 90 to 100 mile an hour winds out here right now at the time of this satellite. So we talked to the emergency manager out there, and he was saying, you know, we've got to get the people out of there. Okay, we got to get these people evacuated. So we then sent out this fire warning. It's the first time we ever did this. And basically, this is what the message was that came across on people's phones to evacuate and to be ready to evacuate, because they got everyone out and no one in those towns were killed. But it's because of the partnership between the media, the Weather Service, and emergency management that keeps you safe. So this was the graphic that we did. This was the fire warning that was sent out. So what happened in this event? Well, These are some of the pictures of what we received through social media and others. Burned a lot of property out there. Buildings were damaged and destroyed. You can see this is the one I've been using for the background, but that's a picture of the fire at night, still really going. Here's some of the other pictures of the fire damage. This is what it looks like during the day, just a lot of smoke and some fields that were burned there. These are some of the winds that blew over tractor trailers on the interstate, and also some more fire damage as well. Out of interest, we went and looked that the satellite will take pictures of certain things because we have very good satellites. And this is the actual fire burn scar, if you will. And so when we're evacuating, Paradise is probably in the biggest problem area there. But this fire reached over 100,000 acres, which is only 0.03%, only counts for 0.03% of less of all fires, okay? It was larger than the size of Wichita, and this is the first mega fire since the Rio fire down in Oklahoma in 2018. But it burned over 121,000 acres. And to give you some kind of perspective of what that means, so the fire's been superimposed over the Wichita metro area, which is basically here. So it's all the way out toward Andover and back toward Goddard. So that's how big it was, just to give you some perspective. The whole area burned. So the Wichita city limits is 166 square miles. This fire was over 200. This is another map of it, and also some of the burn areas down here on the lower left. You can see, but total burned was about 160-some thousand acres, just in one afternoon, and one fire. It took them a couple days to contain that, but it's a pretty big day. These are some of the wind gusts that occurred in the event. You see, Russell had 100-mile-an-hour winds. We also had some ones out there that were in the 90s and 80s. Down toward here, we're mostly in the 70s. There's the Newton County Airport at 66. And it basically was the highest winds were to the north, and as you got less as you went south and east. This is just an event summary of the wind speeds across the country. For this event, you can see Colorado had significant ones, but they also went all the way up into Wisconsin. They had wind gusts in the 70s as well. So it was a pretty historic event. Here's the one of the polar orbiting satellites. Took a picture that night, and they could still see the outline of the fire ongoing that night. So that's pretty rare to see that. Here's an entire loop of the event, just from a satellite perspective. But that was a pretty prolific day in our history. So here's an up-close view of it. So just a summary of the event, we had 4 communities evacuated, Waldo, Paradise, Fairport, and a portion of Luray. Wind and fire damaged hundreds of structures. There were 1,000 cattle killed, 4 injured. 1 was fatal out in western Kansas. Over 121,000 acres were burned. Like I said, over 1,000 livestock killed. They had to relocate another 1,000 because of the loss of grazing area. And there was numerous 70 to 100 mile per hour wind gusts. These are both in thunderstorms and not in thunderstorms, just from the gradient or the strength of the storm. This is the highest number of severe thunderstorm warnings we issued in December for the event. And this is the 3rd largest fire in Kansas history since 2001. So some of the peak winds more locally here, just Russell 100, 95 in New Cambria, and so on. Wichita had 71. And so a big part of what we do is prepare people, and some people like to invent funny slogans like "be prepared and not scared." So how can I help house or apartment, whatever it is, be more fireproof. The first thing you don't want to do is plant those cedars right up against your house, and it's out there. So that is a big fire issue. Second one is make sure you have some kind of a fire break in your landscape. You know, the further away you have things planted from your house, the better. Keep your grass mowed. You know, don't let your grass get up this high. And have a backup plan. You know, what happens if you need to escape, where you want to go? Be thinking of that. So that's all I really had today. I really appreciate your time and coming to attend, and I'll entertain any questions. Thank you.
Okay, if you have questions for Ken, there's a microphone right back there.
Thank you for your presentation. I'm wondering, how does climate change impact the fires and the storms that we're seeing in Kansas, and what might the Weather Service have to offer as we combat climate change?
I can't really speak a lot to the climate part of that. I'm not really a climatologist, but we do work a lot with the state climatology office, Mary Knapp and some of those others, Chip Redmond. The big thing here, I mean, we can argue about the temperature and humidity and these types of things, but we do have things that work together and for and against these things as far as a climate perspective. In the winter, there is a wheat belt that's grown here and extends down to Oklahoma. That actually rises the dew points across the area a good 7 or 8 degrees, and that's pretty well vetted in the literature. And so what that does is actually decrease the amount of, or increase the amount of relative humidity. So that helps us against fires, okay? The other thing that does is because there's more moisture in the air, it keeps the temperatures down in those areas. The issues are what happens outside of that, okay? So during the winter, when we have these large dry spells, it's particularly dangerous, and I wouldn't say it's significantly more anomalous temperature and those type of thing wise over the last 50 years or so, 100 years. What has really changed is the landscape with those cedars. And you can see it. If you just drive by any fields that aren't managed, they're popping up everywhere. And it's because they're either unmanaged or we've been suppressing fire for a long time. So when there's more of them, then they produce even more of them, and it just keeps being an exponential growth function, right? So that's really the biggest issue right now, are those two things. If we are able to get those taken out and return the prairie lands back to more of a natural landscape, you would have more natural fires that don't threaten structures and things like that. But also, you know, as over the years, as people have gone out and moved into rural areas and these types of things, they're putting themselves in that kind of harm's way, whereas back in the 30s, when you would have all these things in 40s, 50s, I mean, there's nothing in the way. They would just burn. So it's just a different world right now. How do we interact with the environment to all work together? And that's the ongoing challenge, I guess. So,
thank you.
You're welcome. Thank you.
You've mentioned fire suppression a couple times, and you kind of hinted that that contributes to the issue. I'm curious if you could talk a little more about that.
I'm sorry, can you say that again?
You mentioned fire suppression a couple times, and kind of hinted that that contributes to the issue a bit. I wonder if you could talk a little more about that.
Sure. So for a long time, the idea from the fire managers and the fire community has been, when they see a fire, go and put it out. And what happens is when you keep doing that, you get grassland areas that are unmanaged, or even this, that just, you get a massive fuel load. You know, you think about if you go out, just in the simplest sense, if you go out and bush hog a field, and you take all that hay off of there and bale it or whatever it is, and you look at the 1-year growth, it's around the same, plus or minus. But if you don't do anything on there for 5 years, now you have a massive fuel load. So it takes less wind, less other environmental factors to burn that because of the added fuel load. And so what we've seen over the years, we have conservation land and these types of things, that a lot of the issues we run into with some of the conservation land specifically is they have a 10-year contract, they're supposed to burn it 3 out of the 10 years. Well, they get to year 7 and they haven't burned it yet. Well, now you have an issue, because if you want to throw a match down on a 7 years worth of growth, that's a lot more than a 2-year or 3-year even. So the fuel loading aspect of that, from that and the fire suppression, has caused a lot of this, where we get the cedars propagating everywhere. But now, like when you get a fire, like the Starbuck fire and some of these other ones, like the first ones I met in Anderson Creek, they let those burn a lot through wildland areas where they weren't a threat to life or cattle or things like that, just to get rid of a lot of that fuel. So there's more, and you've seen this nationwide, there's more of an understanding about how fire works and about fire suppression. And okay, how do you work between the fire suppression and the protection of life and property and the environment, and how all those work together? And that's still an ever-evolving learning process. But that's, I don't know if that answers your question, but that's kind of how we've got to that now. But I would say in the last decade, we're getting more out of the fire suppression and more into fire management. It's probably a more accurate way to say that. So, thank you.
Hello, thank you for coming to speak. I was wondering if you could talk a little bit more about some of the technological advancements, like the satellites or like the different tools that we've used to help gather this information and then figure out how to work and move towards better management techniques.
Sure. So in 2016 and twice since then, we've launched a new array of satellites, and these have a lot, not only a lot better resolution, where you can see down to we do everything in kilometers, so you're down to about a quarter kilometer or even less sometimes, but also you can get it much more rapidly. I mean, when I first got in, we were getting a printout 4 times a day of what the satellite looked like. I don't know how you loop that or make sense of it, but over the years things have improved where we get more pictures, and so now this satellite technology, like what you saw today, not only we get better resolution and it's faster, we also are allowed to look at different wavelengths. So 15 years ago we couldn't look. This is the 3.9, what's that called? It's a 3.9 microwave imagery. So there was no such thing 15 years ago. So now we're looking at all these different wavelengths, and that enables us to see things like dust, fires, and things of that nature, along with the storms that we're accustomed to seeing. And it also, we get a fast enough of a loop of them, so 1 minute data. We can actually get 30-second data if they put the 2 satellite images on top of each other, and we're still trying to work that out, where it's almost like a living loop, if you will, of the evolution of something. So in fires or in severe storms, you can see certain things that happen in the structure of the storm that would give you a cue as to, okay, this is probably producing a very significant amount of hail or large hail and things of that. So there's a lot of ongoing research in how that works right now at the university and our agency level. And so that's the satellite. There's also a lot of the modeling. So a number of years ago, there was the Sandy superstorm out on the East Coast, and what transpired from that is we got big appropriations for more computing power. And so that's enabled us to do not only more accurate modeling, but it's also enabling us to do storm scale modeling. So one thing we're working on is something called warn on forecast. So that sounds like a fancy term, but what we're doing is we're actually modeling storms, and we're warning based on the forecast of what that storm's going to do. So that's still in the test phase. That's probably going to happen in 10 to 20 years where we actually start seeing that more operationally. But that's something that we've been working on now for at least 10 years. And that will eventually enable us to give, right now there's this, how much lead time do you give in a tornado? Because what happens, what do you all do when you get a tornado warning? You run outside and where is it? Most people do that. I do it too, you know, unless it's like, okay, that's 5 miles from my house, but you know, I'm a weather nerd. I'm like looking at the radar and all that. But in general, that's what people do. So we found from social science studies, there's some cross point of people have time to go and shelter in place versus they have so much time, they end up making bad decisions that will get them killed. So where is that? This warrant on forecast is hopefully going to extend past that to give them maybe an hour, or maybe 2 hours of notice to where they can say, okay, I need to get some things together and I can leave the area or go take shelter in a shelter or do whatever it is, get prepared. So that's what we're looking for. So those are probably the two biggest advancements that have happened and are happening in the next 10 years. And the radar, you know, we're doing some neat things with that, but it's hard to move the needle there. That technology's been around for, since 1990, and it's, you know, we've done so much research on that. You know, there's only so much you can do. And we do different scanning strategies with storms, but there's not a lot of movement there. But as far as severe storms go, that's it. So, thank you.
If you're interested in talking with Ken, please feel free to come on up here. Otherwise, you're dismissed once we give him a big Thresher round of applause.